question in this video is, what are the differences between speed and velocity? A lot of times we want to use them interchangeably, and they do have a lot of similarities, but there is a major difference here between them as well. Speed, if you were to talk to somebody about how fast something is going, you're talking about their speed. And so speed is defined as how fast an object is moving. And this would then be the definition of speed. So in your notes, you want to write down in the definition box for speed, it's how fast an object is moving. For velocity's definition, velocity is the same thing as speed, but it has a direction as well. So the definition of velocity is speed with a direction. So again, if at any time you need to pause the video to write things down, feel free to pause the video and get those notes. Some characteristics of speed and velocity. One thing, speed doesn't have a direction. That's why they call it a speedometer, not a velociter, because the speedometer in a car does not tell you the direction you're moving. It only tells you how fast, only tells you the speed. Because it does not have a direction, we refer to it as a scalar, just like distance is a scalar. Velocity, on the other hand, has a direction, just like displacement, and therefore it is referred to as a vector. So all things with direction are vectors, and all things that do not have direction are referred to as scalars. So these in the blue section are to be written in your characteristics. Now, a couple more characteristics. Average speed is computed for the entire duration of a trip. So you can find the average speed of your trip to some new city on a vacation by taking the total distance from your odometer and dividing by the total time. You can just check your watch and divide by the total hours, and that will give you your average speed over the entire trip. Your instantaneous speed, however, is measured at a particular instant, hence the instantaneous speed. Your speedometer tells you your instantaneous speed. It tells you your speed at that very moment in time. Now, to get the total velocity, if you have two velocities that you need to combine together, characteristic is we're going to add the velocities if they're in the same direction. This is very similar to what we do with displacement. So if, for instance, you are in a bus, and the bus is traveling, let's say the bus is traveling forward at 40 miles per hour, and you walk from the back of the bus to the front of the bus at 5 miles per hour. Your total velocity, you would add them together, and you get that total velocity to be 45 miles per hour. But if for some reason, instead of moving to the front of the bus, you were to move to the back of the bus at 5 miles per hour, well, then you're not going to add them. Instead, you will subtract them because they're in opposite directions. So your total velocity in this situation would be 35 miles per hour. They would slightly cancel each other out. So these are characteristics in blue. The next, you can write down the equation. The equation is in purple. And they have the same equation, distance over time. And so we're going to use the same letter as well. We won't use a different letter for velocity. We'll still use a letter S for speed. It's just going to have a direction in addition to the number. Now what I'd like to do, and I'll show you this later on, is use this circle here to help us with our calculations. If you're not solving for the speed, or instead solving for the distance, then your speed and time are next to each other, and you will multiply them. So I'll show you that then as we go through some problems. Some examples of speed and velocity. Examples 50 miles per hour or 20 meters per second would be examples of speed. Velocity would have the same type of examples, but they, in addition to that, have a direction. So we might have like 30 kilometers per hour, but we'd have to say a direction like south. or we could say 15 meters per second. But again, we'd have to have a direction of something like east. The units of speed and velocity turn out to be the same. In this class, we are going to use meters per second for the most part. But some other common units would be things like kilometers per hour, and also miles per hour. The next thing that we want to do is we want to go through some problems and actually solve some speeds or distances or times. So if you need to finish writing the notes, I'd say at this point, pause, finish your notes, and then unpause when you're ready to continue. Okay, in this first problem, this would be on the other side of your paper, it says that Thomas decided to walk to the pencil sharpener during class. He walked a distance of 7.5 meters in a time of 4 seconds. What was his speed during this walk to the pencil sharpener? Now, the first thing we're going to do whenever we solve problems, we always have to show our work. And so the first thing we're going to write down is what letter each number represents. I see two numbers, 7.5 and 4. Now, the letters in my formula are D, S, and T. We want to know what letter 7.5 represents and what letter 4 represents. To help you out in figuring out which letter each number represents, it's important to look at the words before the number. For example, 7.5. It says he walked a distance of 7.5 meters. So out of these three letters, D, T, and S, we want to think about what letter stands for distance. Well, usually the first letter of the word is the letter we use to represent it. So distance is D, and that's the 7.5. So in your menu, this is where we're going to write down everything we know. We're going to write down that D is 7.5. Next, we have the 4 seconds. And again, we look at the words before it, and that'll help us figure out what letter each one represents. It says that it is a time of 4 seconds. And so we want to figure out, is T or S represent time? And again, usually the first letter represents what the value is. So T stands for time, and that time is 4 seconds. Then we put a question mark with what we're trying to find. And the question is, what was his speed? So we are looking for the letter S. Now, when using this circle, we're going to use a circle to figure out what is our equation. We want to find the letter S. We have D and T. So looking at the D and the T, because they are above and below, that means to divide the two. So because the D is above the T, in math, that means to divide the distance and the time. So I'm simply going to look at what letters I know, and then I'm going to copy what to do from my circle. The next thing we do is we show what numbers we're putting into our calculator. Instead of the letter D, we're going to put the number 7.5. Instead of the letter T, we're going to put the number 4. So now in my calculator, I type in 7.5 divided by 4. And I get my answer for the speed. And it comes out to be 1.875. Now it's okay to round off. You put 1.9 or maybe 1.88. But we do need units. Looking back, my options for units, I'm going to go back a page here. My options for units are either meters per second, kilometers per hour, or miles per hour. Looking at my menu, I was using meters and seconds. So out of those options, I want meters per second. Let's look at one more problem. While hiking on the Haleakala Trail in Hawaii, Mrs. Hopwood walked for 2.25 hours at a speed of 4.1 kilometers per hour. How far did Mrs. Hopwood walk? What I'd like you to do right now is pause the video and write down what letter each of these numbers represents. Okay, what you should have written down was that the 2.25 hours was the time. Hours is always measuring time. It didn't say a time of, but the hours, the units, always give it away. You should have written for the 4.1 kilometers per hour, it says a speed of. So that's our letter S, 4.1 kilometers per hour. And we want to find the letter D. Now we want to figure out, what do we do with the S and the T to find it? Do we multiply or do we divide? If we look at the S and the T in our circle equation, we notice that they are written side by side. When things are written side by side in math class, that means to multiply. Now we'll put in our values. Instead of S, I'm going to write in 4.1. And instead of T, I'm going to write 2.25. When I type in my calculator 4.1 times 2.25, I get an answer of 9.225 for a number. But I do need a unit. My unit in this case, looking back at my menu, my unit for this one is going to be kilometers, because that's what was used in my speed unit as well. So again, speed and velocity are really the same type of thing. The difference is that velocity has time, direction in it. Velocity has direction in it. Speed does not. And one way to remember that is speed is a scalar, because they both start with the letter S, whereas velocity is a vector, because they both start with V. But regardless of if you're calculating speed or velocity, the formula is the same. Speed or velocity is distance divided by time.